Welcome to Learning Calculus by Allison. This is episode 2 where we're going to be learning definition of derivative. Alright, so here we have our two equations. The one on the top will be used to find your slope, and this one you will use if you have a point to use and plug in. So here we have our first equation, f of x equals x squared plus 2. So what we're going to do first, for every problem, we're going to write our definition of derivative, which is, of course, f prime of x equals the limit as delta x approaches 0, and the equation is f of x plus delta x minus f of x all over delta x. Alright, so what I did here was I went ahead and wrote everything out for you, but we're going to walk through it step by step. So your first step is to plug in this into this. So what you're going to do is it's going to be x plus delta x as here, and you plug it in for your x. So it's squared. And then you just add the 2 because that's the rest of your equation. Since it's f of x, you simply write out this equation for the second part, so it's x squared plus 2. For step 2, I went ahead and wrote out little numbers for you to see. For step 2, you're going to FOIL this, so it's going to be x squared plus 2x delta x plus delta x squared, and you keep your 2 plus 2. And I went ahead and distributed the negative to make these subtracted. In step 3, you simplify and get rid of everything unnecessary. So in this case, x squared is going to be crossed out, and so is the 2. So you're simply left with this. So it's 2x delta x plus delta x squared all over delta x. Step number 4, you're going to take out the delta x because it's common in these. So you can see you have a delta x here and a delta x here. So that leaves you with 2x plus delta x all over delta x. The next step, step number 5, you're going to cross out the delta x if you need to show that it's gone. And so you're left with 2x plus delta x. And finally, you plug in 0 for delta x because that's what the limit, or delta x is approaching. So this is a 0. So it's just 2x. A couple things you want to remember is to carry your limit all the way down until you actually substitute, because then after that you don't need it, and if not, you'll get counted points off. This is going to be our example to find the point in a derivative. So your f of x equation is going to be x squared minus 3, and you're looking for it at the point 2, 1. So here's your definition again. F prime of c equals the limit of x approaching c of f of x minus f of c all over x minus c. Since we're looking for c, c is always going to be your x value, so in this case it's going to be the 2. So what I did again was I wrote it out, and we're going to go over it. So first thing, it's very similar. So first thing you're going to do, of course, is you're going to plug it in. So you have your f of x equation, which is x squared minus 3, and you're going to subtract f of c. In this case, what you do for f of c is you plug in what your limit is approaching, so that would be 2. So it's 2 squared minus 3. So all over x minus 2. You're going to have 4 minus 3, which gives you 1. So it's still your x squared minus 3 minus 1 over x minus 2. The next thing you're going to do is you have limit as x approaches 2 of x squared minus 4 over x minus 2. So if you went off of this and you plugged in the 2, it would be 2 squared minus 4 over 2 minus 2, which is 0 over 0. We know that's incorrect, so what we do is we continue on and we simplify, rationalize, whatever you want to call it, and we do x minus 2 and x plus 2 because that's what consists of x squared minus 4. And we continue to put it all over x minus 2. So what you're going to do here is you're going to make sure you know this is crossed out, and you end up with the x plus 2. So you have the limit of x approaching 2. So then you have 2 plus 2 equals 4, and 4 is your answer. What you want to make sure you do again is carry your limit all the way down until you substitute again, so you don't get any points taken off. And you want to make sure that you know this is your c value, and you don't plug it in until you do the f of c equation. Thanks for watching.